All right, ready? If I ask you what the cosine of pi over 6 is, we did this on our quiz. Yo, your phones are not anywhere near you. Put it in your backpack. Bury it deep down. Throw it over there right now. Everybody else, don't you dare have your phone anywhere near you, and it should be over there on the other side of the room. Because I wasn't in on Monday. We'll do it after this test. Step 1. This would have been a great question for the note card, which we'll do in the future. Okay. Step 1. We locate the radian measurement. We make sure you understand the reference angle. Cosine of pi over 6. Okay, great. Pi over 6, we remember, creates a 30-degree angle. Pi over 4, 45. Pi over 3, 60. Here is pi over 6. It creates a 30-degree angle. You draw your terminal ray, you stop at 1. You connect it with the unit circle with a radius of 1. You then draw your triangle that you know. Oh, great. There's a short 30, 60, 90 triangle that I know. There's a tall 30, 60, 90 triangle that I know. And there's a 45, 45, 90 triangle that I know. Draw those triangles, please, and label their side lengths because it's very, very important. You don't care about all the angles. You care about the base angle. This is 30, boom, short side, longer side. Hypotenuse 1. If it's the tall-oriented 30, 60, 90 triangle, this is 60 degrees. This is the short side. This is the long side. This is 1. If it's the 45, 45, 90, the leg lengths are the same. They are root 2's over 2. Great. We then take those lengths and we put it on top of our triangle in our circle. Root 3 over 2, 1/2. We finish off with so, ka, ta. Cosine, adjacent over hypotenuse. Thank you, hypotenuse being 1. I don't have to divide by anything. Dividing by 1 is not going to change anything. So, root 3 over 2 is my answer. Let's review. We've already done that. Okay. What is new? Pause. Pause. What is new? We are going to be in different quadrants. What is new is that if we are in different quadrants, direction matters. What do I mean by that? This is an x-axis and this is a y-axis. It may seem odd, but we're going to go with it. If you're moving to the left on the x-axis, you're going to consider length to be negative on triangles. If you go down on the y-axis, you're going to consider y length to be negative because direction matters. Okay? That's what's new, is that we are going to place our triangle, but we are going to pay attention to direction. Cool. We are going to get out of acute land, and we're moving into obtuse land. Now, we are going to start with 3 pi over 4. Start by drawing an x and a y axis and locating 3 pi over 4. Where's 3 pi over 4? Draw your terminal ray. I don't believe it.
wasn't talking.
Draw your terminal ray and draw your reference angle. You should be going to 4 pi over 4. You should be subtracting a pi over 4. You're here. Now, 3 pi over 4 is this arc length of the unit circle. What is very, very important, but takes a long time to prove, which you guys will just kind of go with because it works out so nicely, is this fact. 3 pi over 4 is like 135 degrees. The trig function of an obtuse angle is equivalent to the trig function of your reference angle. They're the same. Proving it is a little complicated, takes much time, but just go with it, okay? You'll be fine. Okay. What we do now is we draw our triangle, but it's in the second quadrant, so we're going to just pay a little bit extra attention to how the triangle's made, which directions we go in. We know it's a 45, 45, 90 triangle. First of all, you're drawing your terminal ray. You stop when it hits the unit circle. You're going to be like, yo, I'm going to label that hypotenuse as the radius of 1. And then you are not going to connect with the y-axis ever. We've always talked about the reference angle being referenced to the x-axis. So we will make sure we drop or bring up the leg to the x-axis. That creates our 45, 45, 90 triangle, whose side lengths you know, but whose one side length is different than what you've seen before. Tell your neighbors what's the one difference with this triangle than the pi over 4 triangle that we've already drawn. Right. We are going to the left on the x-axis, so we would label this side length as negative root 2 over 2. We would still label this side length as positive root 2 over 2 because we're going up. All right, what's the sine of 3 pi over 4? What's the cosine of 3 pi over 4? Go. Say, neighbors, what's the sine of 3 pi over 4? What's the cosine of 3 pi over 4?
45.
Yeah, sine is the opposite over hypotenuse. Oh, guess what? Don't have to worry about dividing by 1. The sine is the opposite of my reference angle. The sine of the obtuse angle is equivalent to the sine of the reference angle. The cosine is the adjacent. Okay. Please tell me what the sine of 2 pi over 3 is. Please tell me what the cosine of 2 pi over 3 is. Please tell me what the tangent of 2 pi over 3 is. I'm not doing anything. You do it. See if you can do it. All that's different is just paying attention to direction. Go. Okay, cool. I was going to mention that after we did this. since we're going left. Cool. So the answer, so. Well, I mean, you can, but not in this situation. The sine is positive root 3 over 2. The cosine is negative 1/2. The tangent is negative root 3. Now, how do we get that? The following way. Start with pi. Subtract the pi over 3. 60-degree reference angle. Create it. Don't connect it with the y-axis. Drop it down to the x-axis. If anybody's making any mistakes, it's usually they connect it with the y-axis. No. We found that location by knowing pi over 3 is 60 degrees away from the x-axis. So remember that. We label our side lengths of our tall 30, 60, 90 triangle, paying attention to direction. Sine, opposite over hypotenuse, boom, there's my root 3 over 2. Cosine, adjacent over hypotenuse, boom, that's my negative 1/2. Tangent, root 3 over 2 divided by negative 1 over 2 is root 3 over 2 times negative 2 over 1, which ends up being negative root 3. Yep, we'll come back. What's the sine of 7 pi over 6? What's the cosine of 7 pi over 6? Now, maybe do this next one by writing everything down. But after doing this enough time, you can get to the point where you can do everything in your head. Take your time before doing that. But, do one more for me, and then maybe when I start giving you some rapid fire ones, see if you can do it in your head, okay? Let's all draw it out, no matter what. But know that our ultimate goal is actually for this to be just like brain. Draw it out first. That's 11 pi over 6. If you have been always writing 6 pi over 6 plus pi over 6, good. Keep doing it until you don't have to do that step anymore. Until you're like, I got that. If you've been drawing your triangles, which most of you are definitely doing, good. Keep doing that. But eventually, you won't have to do that. If you've been drawing representative triangles somewhere and then like copying down the correct things, good. If you put that the sine of 7 pi over 6 is negative 1/2, great. If you put the cosine of 7 pi over 6 is negative root 3 over 2, great. You're nailing it. Sine, opposite over hypotenuse, I don't need to divide by 1. If you've been dividing by 1, good. Eventually you're going to realize, oh yeah, I don't need to divide by 1. The hypotenuse is 1. If you forgot, because it's new, you're going to know from now on, direction matters. We're going left and down, which is why both side lengths I'm going to call negative. All right. Oh, great question, which I should have brought up earlier. Everybody go back. Pay attention to direction. For everything except for the radius. My radius is always positive. Radius is always going to be a positive distance for now. coming from the origin. In the future, we will be talking about a negative radius. No, like 2 or 3 units down the road. But it's not crazy. It's just like if I said draw a triangle at pi over 6 with a radius -2, you would go to pi over 6, but instead of going out, you'd go the other way. But don't worry about that. We're going to just consider radiuses to be positive. Okay? Radiuses are always positive. So even though this is in the third quadrant, we're going to call the radius positive. Thank you. Great question. For what? Secant?
One of them.
Cotangent?
Both of them.
Secant, reciprocal of the cosine. Cosine, we already did. Secant flips. Secant would be -2 √3 over 3. The negative can be anywhere. We don't change the sign when we flip and take reciprocals. This is not like perpendicular slopes. Cotangents, adjacent over opposite versus opposite over adjacent. Adjacent is √3 over 2. Opposite is -0.5. This ends up being a negative over a negative, which makes it a positive √3. Have you gotten that right? Great. If you didn't, that's okay. Well, the first time we're trying this, and just like you'll make sure you know that in the future. Skip this. We'll come back to it. Please, doing all of the steps. Tell me what the sine of 5 pi over 3 and the cosine of 5 pi over 3 is. Then tell me what the cosecant of 5 pi over 3 and the tangent of 5 pi over 3. Doing all the steps, showing all the work. The one thing being new is pay attention to direction for x's and y's. R's are positive. Now, words of advice, be exaggerated with your terminal ray. A 5 pi over 3 creates a 60-degree reference angle. When I draw my 60-degree reference angle and my 60-degree terminal ray, I'm like really, really close to this 3 pi over 2. I am really seeing short side and long side. If people are making mistakes, it's because everything ends up looking like a 45, 45, 90 triangle. Even though you're like 60 degrees, you know? I'm going to be like exaggerated 60 degrees. So I really can see the long and the short. Now, if you're always used to being like 60 degrees, will be opposite the longer side, that's fine. 30 degrees opposite the shorter side, that's fine too. But I'm making sure I'm like more exaggerated when I'm drawing my triangle. Okay, what's the sine of 5 pi over 3? What's the cosine of 5 pi over 3? Get it and tell your neighbors. Yep. The first two are. I didn't look at the last two. You're not labeling the triangle length.
Because I tried to do it without
Drawing it? Well, draw it, because you didn't get it right. Nice. Good. Nice. We can build on that. Okay, that's the one thing we're getting wrong. Let's just like fix that, and that's a minor problem compared to getting that, that's the big problem. Okay. Dividing by fractions, keep change flip. Dividing by root 3 over 2 is the same as multiplying by 2 over root 3. That's your answer, 2 over root 3. But it's not perfect. We're going to rationalize the denominator. We're going to get rid of the radical in the denominator. Multiply the top and bottom by root 3. Yeah. After we flip. All right. I'm about to go rapid fire. In a second after we talk about this one. Again, the hypotenuse is 1. It's great that we have this hypotenuse of 1 because I don't have to worry about 8 so much. Sine, opposite over hypotenuse. Well, the hypotenuse is 1. I just have to worry about the opposite. The cosine, adjacent over hypotenuse. Well, I don't have to worry about the hypotenuse. It's just 1. Cosecant, sine flipped. Here's sine. It's hypotenuse over opposite. You can write it as 1 over negative root 3 over 2, or just flip it, and you get 2 over root 3. You can put the negative anywhere. We rationalize by multiplying the top and bottom by the square root in the bottom. This becomes 2 root 3 over 3. Root 3 times root 3 is just 3. Keep the negative somewhere and you're good. Tangent, opposite over adjacent, negative root 3. Okay, go back to the second quadrant page, and we're going to cross off this and we'll rapid fire some things. The bottom of the second quadrant. Okay, now, if you feel like you have no chance, write everything out. If you feel like you want to challenge yourself a little bit, do one step in your head. If you want to challenge yourself a little bit more, do a couple of the steps in your head. Eventually, we should be able to just be like, boom, I know what the sine of 5, 5, or 6 is. Just by thinking about everything all at once. Everybody, try to figure it out in your own way. Maybe try to do it in your head, but maybe you're writing stuff down on paper. Sine of 5, 5 over 6.
Oh.
Sine of 5, 5 over 6.
Do I have to draw it?
You don't have to draw it, but like, get it right. And if getting it right requires you to draw it, draw it. $150. No, that's the angle measurement. The sine is the ratio of the triangle created at that angle. I want you to answer the question. What's the sine of 5, 5?
You want us to write it down?
I want you to get it right. 5, 5, or 6.
I don't understand.
You got it? What is it? You're right. All of them are wrong. Sorry. What's the answer is positive 1/2. Okay? Now, if you didn't get it right, you probably need to go backwards. And you need to remember, oh, it's pi minus pi over 6, which creates a 30-degree angle in the second quadrant. Positive 1/2, negative root 3 over 2. Opposite over hypotenuse, positive 1/2. Okay, rapid fire, rapid fire, rapid fire, rapid fire. What is the cosine of 7 pi over 4? Either you do it in your head and then use your piece of paper until you got it, okay? Yep. 7 pi over 4 is not straight down. 7 pi over 4 is 1 pi over 4 away from 8 pi over 4. The answer is positive root 2 over 2. If you didn't get it right, here's probably where you're making mistakes. So go back, make sure you know. 8 pi over 4 minus a pi over 4 takes you to the fourth quadrant. Woods, I'm going to take your phone and put it over there. Yes, you broke it out, and I know it. I got eyes like a hawk. Root 2 over 2 is the adjacent. Go, do it right now. Negative root 2 over 2 is the opposite. Cosine is the adjacent. Positive root 2 over 2 because we're going to the right. All right, rapid fire, rapid fire, rapid fire, rapid fire. What's the sign of 4 pi over 3? Don't tell your neighbors. Figure it out. All right, cool. Don't think out loud either. Whisper and use your fingers. And you know what? When I do this in my head, I use my hand. Sine of 4 pi over 3. I use my hands when I do this, or a pencil. Yeah, like I literally am like, okay, 4 pi over 3 is there. Like that helps one less step in your brain. Go ahead and use a pencil if you need to. Look at life coach, just laughing at y'all. You're wrong too. You're wrong, Thomas.
Is it square root 3 over 2?
No.
Why not?
No. Yeah. All y'all have gotten it wrong. All gotten it wrong. Hit the brakes. Okay? You need to keep drawing stuff because you're wrong. You've been wrong. It's negative root 3 over 2 because 4 pi over 3 is 1 pi over 3 more than 3 pi over 3. It's over here in the third quadrant. The reference angle is 60 degrees. I go to the left and I go down. The sign is negative root 3 over 2. All right, rapid fire, rapid fire, rapid fire, rapid fire, rapid fire. Now, everybody needs to write down something because not even I do this in my head very well. What's the tangent of 11 pi over 6? I use my pencil if I'm doing this in my brain. And then I use my fingers with the length sometimes. Yeah. Write it down on your piece of paper and tell your neighbors if you got it. Good. Write down on a piece of paper. Let me see if it's right. No.
Oh, wait, no, negative myself.
Nope. Nope.
I wrote it up here. That's a 3, by the way.
Nope.
That's a 3. Oh, okay.
Nice one. Nope. Is that a 4? No. Nope. We got bugs. Oh man, a lot of you are writing the right fraction down, but then you're not dividing it correctly. The answer is negative root 3 over 3. And here's the reasoning behind it. Many of you need to pump the brakes. 2 pi minus pi over 6, 30 degrees. Opposite is negative a half. Adjacent is root 3 over 2. Tangent is opposites over adjacent. Keep, change, flip. Stop. Dividing by a fraction is the same as multiplying by a reciprocal. Negative a half times 2 over root 3 is negative 1 over root 3, which is negative root 3 over 3. If you need to practice rationalizing, you need to go back to like day 2 homework and really the beginning of today's homework. Like, make sure you know how to find the cosecant of 5 pi over 3. Make sure you know how to find the secant of 5 pi over 3. Make sure you know how to find all the tangents. Don't just copy down the answer. Many of you are messing up on just the simple division part of things and the rationalizing part of things. That should be the minor part of things, not the major part of things. One more, somewhere. Find some space. What's the secant of 5 pi over 6? The secant of 5 pi over 6. Write it down if you have it. Let me see if you got the right answer. Write it down. Or use. Yeah. Use your paper to write it out. That's it. Yeah. That's a negative?
Yeah.
Yep. Write out the angles, guys. If you're not there yet, it's okay. Trust me. Like, I'm challenging you. But if you're like, I'm not there yet, just be like, it's okay, I'm not there yet. Where's 5 pi over 6? You know, draw your triangle. Do it. Where's your answer? Nope. You can't. It's reciprocal. No. Nope. Where's your answer? Okay. Sorry, you're wrong, McCarty. All right, team. If you have not gotten all but one of these right, try it in your head. Stop trying in your head until you're ready. 5 pi over 6. A lot of you are probably not getting it right because you're not writing 6 pi over 6 minus pi over 6. Okay, that's the first thing. Next thing, a lot of you are not getting it right because you're not drawing your triangles. You're not going 1/2. You're not going root 3 over 2. The next thing, you're not writing that the secant is the flip of cosine. The next thing is you're not finding the cosine of 5 pi over 6 and flipping it. The next thing is you're not paying attention to the direction, or you're not understanding the correct reciprocal function. This is not what I'd want, though. I'd want you to rationalize this. The answer is negative 2 root 3 over 3. Okay? All right. Now, what are some additional problems? Let's go to this problem right here. And I'd like you to change this to 2 pi over, let's go to a 2 pi over 3. Yeah, 2 pi over 3. Okay. New question, new challenging question, but really it's only a combination of day 1 and today. If you remember day 1 and you understood day 1, this question should not blow your mind. Here's the first thing. I'm going to kind of walk you through this question. Let's just look at 2 pi over 3 and its triangle with a radius of 1. Here we go. 2 pi over 3 is 1 pi over 3 less than 3 pi over 3 is here, the 60-degree angle, and here's the triangle that I created. Negative 1/2 is the x, and the y is root 3 over 2. Cool. Now, here's the key to the connection of radians and these triangles is the fact that this triangle has a hypotenuse of 1. That's the radius of my unit circle. This arc length is 2 pi over 3. That's the radian measurement, connects with the 60 degrees, connects with the triangle. This point here is where the triangle or the terminal ray intersects with the circle. Focus, blank stares. Could you give me the coordinates of this intersecting point? Write them down. What are the coordinates of that intersecting point? This is very similar to the quiz question you had where I gave you a point and you realize it's like, oh, that's just an x and a y. -1/2 root 3 over 2. Now, for something different, what if this terminal ray kept going? And what if that terminal ray eventually intersects with a circle radius 12? Here is a circle. It's coming at you shortly of radius 12. That's not it. Here it comes. I'm probably going to do a circle radius 12. Oh. Okay, now we have a circle whose radius is 12. This terminal ray of 2 pi over 3 will intersect that circle of radius 12. What are the coordinates of that intersection? Tell your neighbors and tell them why. It really goes along with the question you had on your quiz today, with the questions you had on your quizzes on Monday or on Wednesday. You know what? T. Ford said it, and I didn't even think about using this word the entire unit so far until T. Ford said it. He said, yo, scale it. Scale it. Make it bigger. That's exactly right. I've been calling it like multipliers, but yeah, we're just scaling things. Make everything bigger by multiplying by 12. You multiply everything here by 12. You'll get this arc length, which will be 8 pi. This arc length is 8 pi, because what did I do? I multiplied this arc length by 12. This radius becomes 12. This becomes -6. This becomes 6 root 3. You just multiply everything by a multiplier and you scale it. That's the word I've been looking for. Scale it. I don't want 1 anymore. I want 12. Root 3 over 2 times 12. 6 root 3. -1/2 times 12. -6. The coordinates of this point here are -6, 6 root 3. Okay? Same deal. Down here, I got an angle of 7 pi over 6. I have a radius of 8. Please tell me what are the coordinates of the intersection between this terminal ray and the circle radius 8. What are the coordinates? Scale your unit circle knowledge at 7 pi over 6, and that's the answer. See if you can do it in your head. If you can't, don't. Tell your neighbors, what are your coordinates of this intersecting point of a Terminal ray 7 pi over 6 that passes through a circle radius 8. The answer is -4 root 3 and -4. How did I get that? I got 7 pi over 6, 30 degrees away from pi, -1/2, -root 3 over 2. I then want to change the radius of 1 to 8. I multiply everything by 8. I scale it. It scales everything. It scales the arc length. It scales the x's. It scales the y's. It's all good in the hood. What if we go backwards? Change this to positive. Oh, nope, don't change it. Keep it where it is. We got coordinates. What's the angle and the radius of the intersection between a terminal ray and a circle of a certain radius? What's the value of theta and r, A, B, C, or D, if those are the coordinates? Not B. It's B. Now, here's something that will help you if you're like, I have no idea. First thing is like, we're only going to give you questions involving 30, 60, and 90 triangles, okay? Or 45, 45, 90. Will this point intersect with a 45-degree angle? No way. Because if it was a 45-degree angle, we're talking about what? Isosceles triangles where the x and the y are the same. The x and the y are not the same. So it's not a 45. It's got to be a 30, 60, 90. The next thing I know is that 5 times the square root of 3 is bigger than 5. That means the 5 root 3, which is the y length, is the longer length. I'm going to the left 5, but I'm going to go down more 5 root 3. And then, guys, think about your representative 30, 60, 90 triangle. What's your multiplier to take a half and make it -5? What's the multiplier that takes -3 root 2 and makes it -5 root 3? It's 10. That's why it's C. That interesting stuff.
Well, you can also use Pythagorean theorem.
Or you can use the Pythagorean theorem, McCarty. It's very good. But I like to scale.
That was faster than
That's fine. Have a